Hello everyone, welcome to OpenPlant Tech Tip Tuesday. I'm Abbas Ali Zaidi, and this week we are going to go over a user question that I got recently. They're trying to create some custom or user-defined wafer valves and creating a new end condition for it, and want that end condition to behave the way our wafer ends or lug ends behave. So the question was that how to create these custom end conditions and have them behave like wafer ends.
So in order to answer this question, we'll need to look at what type of flange joints are currently available in OpenPlant Modeler and what type of customization do they offer. So let me start by placing a few flange joints that we have. And also I've created a user-defined wafer end with slight modification. It's a combination of a wafer and lug joint, and then we will see how they were actually implemented. So let me just zoom into our model here, or maybe just place them in space. Okay. First, let's place a simple flange connection. So the two flanges, whenever they're combined, we place a gasket and a set of bolts. So this is a regular flange end condition. Next, we'll place a few wafer ends. So this is a regular wafer end butterfly valve. And let me just place it here. And now I'll connect some mating flanges with this valve. It's asked for gaskets and a set of bolt which are partially threaded through bolts. So when I was placing a wafer end, it asked me for gaskets on both the ends and just one set of bolts which are through bolts on at the time of completion of the joint. So I can continue to connect multiple wafer-ended components together, and each will have a gasket inserted. But once we close the connection by joining a mating flange, only then a through set of bolts will be inserted. Besides this, we have what we call lug joints. Let's just insert a lug end valve, and with this lug end, when we place mating flanges, the behavior is slightly different. And we are asked selection of gaskets and fully threaded machine bolts at each end. This is a regular behavior of a lug joint that you have, although the component is a sort of wafer in nature, but when you connect it with mating flanges, fully threaded machine bolts are inserted at each end as well as the gaskets. Now, another option that we have in OpenPlant Modeler is what we call uh, wafer lug end. This connection is although defined in our schemas, but the user has to, for now, do a slight customization or modification of the specs and the configuration variable to get it to work. I have it working here, and first let me show you what the behavior is. So with this wafer lug end, the when we place mating flanges, it puts up gaskets on both the ends as well as fully threaded machine bolts at both the ends and one set of partially threaded through bolts. So this is a combination of a lug and a wafer joint, and it places three set of bolts and two set of gaskets. So let me just quickly check. Only select the fasteners, see element information, and as you can see, I have one set of bolts which are through bolts, maybe partially threaded, and I have two gaskets at each end, as well as two set of machine bolts at each end. I defined a custom wafer lug end and tried to mimic the behavior of this wafer lug end with one slight change that I didn't want any gaskets this time inserted between my joint. So how did I do that? First, let me just insert that component. I defined a end conditional called wafer user defined and created a dummy record of a butterfly valve with that end condition. So let's just place it here and now attach mating flanges. So when I attach mating flanges, notice that no gasket options are offered and no gaskets are placed in this, and only the two sets of machine bolts as well as one set of through partially threaded bolts are inserted. So let me just do a selection set here. As you can see, I have one bolt and two set of machine bolts to make this connection. So how did we do that? In order to implement these joints, primarily the changes need to happen at two places. One is the configuration variables, and the second are schemas. Of course, you need to have corresponding specs and database records for the component with the particular end prep that you're trying to place. Let me bring in the modular CFG file here. In the VHI, this would be the PCF file. So we have three configuration variables. The first one is OPM custom wafer type end preps. If you're defining a new end condition and want it to behave like a regular wafer end, just add that end condition here. In our case, I added these two end conditions, wafer lug end as well as wafer user defined. So this is just a dummy name for an end prep that I added for demonstration. If you're adding some end conditions which you want to behave like flanges or some end prep that you want to be categorized as a weld, there are certain end conditions that you want to use in the trimming. We only trim the butt weld type end prep, so these plain ends can be taken into account into that operation as well. For this particular example, adding an end prep here would do. So that's one change. And now let me open up the schemas. We've opened up OpenPlant 3D schema, supplemented it with our supplemental modeling. Here you can see we have a regular flange joint defines where the flange end is capable of connection with another flange end or lap joint ends. When we see these mating flange ends, we have an option to insert either a bolt or a stud bolt and a gasket. So similarly, if you scroll down in the schema, we have a definition for wafer and joint. Again, if you see the two end preps required to form a wafer joint, these are one wafer end can be joined with a flange end, another wafer end, or also a lap joint end. And when that happens, we insert gasket and stud bolts. Another joint that we placed was our lug joint, where we used a lug end that was connected to a flange end, and in that case machine bolts, let me expand the fastener. In that case, gasket and machine bolts were placed. So these scripts name Bentley building.mechanical joint scripts are the assembly names, and the actual script class is defined here. Again, they contain the logic for how to calculate some of the bolt lengths as well as the insertion of the bolts. These are exposed for our users to go ahead and customize, but in itself, it will be a whole class to go into the how the joint scripts work. The joint of interest here is wafer lug joint. Again, this is a combination of wafer lug end as well as it can be combined with either flange end or another wafer lug end. So this joint basically puts up a gasket at each end and inserts machine bolt at both the ends and one um, one stud bolt or a bolt which is a through bolt. Again, the logic of putting up two machine bolts and one through bolts and calculating their lengths resides in these scripts. You can take example of any of these joints while creating your new joint and just go to the top of the joint definition, do a right click and add element. What it does is that it adds a structure of a joint definition. So this is the joint that I just added called custom wafer lug. I intended to create this joint with my new user defined end condition called wafer user defined. I had added this wafer user defined end condition in the CFG variable so that it gets classified as a wafer end, behaves like that. And I'm using the same scripts, so I want the same behavior of machine bolts getting placed at both ends and through bolt. But I removed the gasket from the list of fasteners, so now only the bolts are placed. So this way you can customize your joint. One last thing in the schemas that you'll have to do when you create a new end condition is add that end condition in the weld value map. So in the properties tab of the weld value map, scrolling down, these are the end conditions that I added: a wafer lug end, and this corresponds to the entry of end preparation in the spec record, as well as the custom user end that we created, which is called wafer user defined, and the spec record will have the value of CLG in this case. Right, so these were some of the non-standard records that I added for demonstration with lug, WLG corresponding to our wafer lug, and the CLG corresponding to our custom user defined end.
Okay, so this week we went over the wafer end, different type of options we have in OpenPlant Modeler to customize the wafer lug ends and how to set up a user-defined joint system that behaves like a wafer-ended system. So I hope you found this useful. Thank you.